You have a great idea for a game. You've drawn some beautiful character art. You got some wonderful maps, and you got this awesome idea for a battle system, and if you could just get it into Unity properly, everyone would love it. But boy, Unity is not cooperating. You've got some, like, art in the game world, but there's no game. You tried to program some battle system stuff, and it sort of was working, but then it fell apart because you changed the length of an animation. Oh, I don't even want to think about how we're going to do randomized battles, because that's... yeah, programming games is annoying. It requires a completely different kind of software architecture than any other kind of software, and even experienced programmers may not know how to do it properly. So I'm going to teach you the most basic and fundamental method. It's called the control stack. The control stack is a system you can use to build your entire game. It'll make it easy. Miracles, right? Let's go ahead and talk about how it works. Let's show you this little demo I put together. It took me about an hour. So the idea is this is basically an RPG, similar to the way that any other turn-based RPG would work. I don't have a battle system or art, but I have the flow that you would need in order to create those things. And it just goes back and forth, right? Now, if you've ever programmed something like this yourself, you're probably thinking, that's not too hard to do, but then it falls apart, or it's annoying, or, it's just obnoxious. This took me an hour, and it's not going to fall apart. It's very, very solid. I can change almost anything, and it will work fine. Put in 3D models instead of these little icons, works fine. Put in a neutral party, works fine. Make it so that it spawns up when we're doing something in a different scene entirely, sure, no problem. How do you do that? How do you get it to be so robust and so fast? Well, you just have to know how to structure your program, and that is what the control stack is all about. Let's go over to our friend, the empty paper, and go ahead and draw up a diagram of what the heck this is. So a control stack is just a Jenga tower of things that want to control the game. So one of those things is the battle. The battle system itself wants to control your game. Doesn't matter how it gets created. It might be a scene that you go into, might be an object that you spawn, it might be something you just turn on and off at will. Any way you cut it, at some point the battle awakens. And it goes, I have awakened from my long slumber, and I wish for control of the game. And the game goes, okay. And the battle system goes, first hero, step up. Well, now there are two things on the stack. There's the battle controller that wants to control the whole battle, and then there's the hero controller that wants to control this specific hero. The battle system goes, okay, I'm out, because only the one on top of the stack has control of the game. Okay? The hero system goes, don't worry, I got this. I know what to do. I'm going to ask the player which button they want to press. And then the player presses a button, and the hero controller goes away. The battle controller says, oh, I'm in control again. Okay, next hero, you're up. And this hero goes, okay, press a button. And the player goes, I'm going to press the skills button. And the hero goes, I don't know how to do that. I'm going to go ahead and create the skills controller, or turn the skills controller on, or however you want to do that. And now the stack is 3 high. And the skill controller is the only one that's actively in control. The others are just hanging around in the background. And the skill controller has a whole bunch of buttons or whatever. And then the player clicks a button and the skill controller goes, hey, we're going to use heal. And the hero controller might go, okay, well, can you choose a target? So this would go away. And the hero controller would create a targeting system, and then, of course, that would go away when you choose a target, and then we return back to the battle sequence, and the battle sequence would go, okay, we're done with the heroes, let's go ahead and start up the villains. And the villains would go, we're not going to ask the player any questions, because screw that guy, we're going to kill him with animations. Look at all of our glorious, glorious animations. Boy, have you seen so many animations. You know, this animation has like a secret button that you can push at the right moment to start up a menu so that you can choose a specific counter to it, and then that will be another animation. Boy, that looks kind of complicated, right? Well, the villains don't care. The battle system doesn't care. The animations can do whatever they want because we're just hanging around in the background. And until all of those animations have resolved, we're not getting control back because whoever's on top has control. So this animation fades away and the villains are still hanging around in the background. The battle system is still just waiting. This animation concludes and they're still waiting. This animation concludes, still nothing. This concludes, still nothing. Boom. Now the villains get control back and they clear themselves off and the battle system goes, okay, next round. So that is the process of how a round would go. And it just pops up different animations. And I know that looked like theory, loosey-goosey theory, except that's literally what you saw when I pressed play. So how can you implement that? Your game might not be exactly the same as this. You might have other options, other things you want to do. Yeah, no problem. No problem, because what you're going to do is you're going to get a piece of paper and a pen. Don't try to do this in a spreadsheet. Get a piece of paper and a pen, because it's much easier to doodle this with a free hand than try and work out how to draw trees and icons in a spreadsheet. So I'm going to show you how I do it when I diagram out my game, or part of my game, because this can just be one little part. You don't have to diagram out the whole thing. You can leave a lot of stubs and only put them in when you actually need them. But for the sake of this, it's a small system, so we're going to go ahead and diagram it out in full. This is one of our controllers, the battle controller. Here, we use this icon, which means each. And then we say hero. Now, this is a little bit different from the gameplay diagrams that you might have read about, because these are not about gameplay. This is about classes that want to control the game. So when we say that the battle controller should create each hero controller, or should activate each hero controller, we're not saying that that there's some kind of gameplay element here. We're saying literally there is a class in the game world, and the battle controller will turn that class on and off and on and off. So this each means that the battle controller turns the hero on, and then when the hero turns off and returns control back to the battle will turn the next hero on, and until it runs out of heroes, however many heroes that might be. Then over here, we've got our villains. Depending on how you build this, there are a lot of options for how you want to wire this up. For example, you might do it like this, where the battle controller goes through each hero and then the battle controller goes through each villain. There are reasons why you might not want to do that. And in my case, I have my own separate villain controller. There are a lot of approaches to this that you can take, and I'm going to explain why I did the villain controller on its own like this later. As I've said, the villain is mostly responsible for creating animations. So these little dotted lines, that means that it's an arbitrary number of them. So it's animations, any amount. How about the heroes? What do they do? Well, one of the things that the heroes can do is a targeting system. Now, I don't actually have the targeting system built, but basically you click attack and then you choose a target and then anims. Right? Basic stuff, right? You can also open up the item or skill menu. Since they have such similar functionality, I just go ahead and list them like this. And then they also choose a target. And that is it. That is the extent of what I've shown you. And for most of you, if you're building an RPG battle engine, this is going to be quite close to what you need for your engine. You don't need to have much more complex stuff. Now, how do you actually make this into a game? How do you program it? How do you wire this stuff up? There are 5 functions that control how these classes move and how these classes work. Let's go ahead and talk about them. The two biggest, the two most fundamental, are on enable and on disable. These run whenever the object turns on or off. It doesn't matter how the object gets turned on or off. If the object is created, then obviously it turns on. If the object is turned on, it was in the scene just not turned on, then it gets turned on. So when it gets turned on or turned off, these get called. So when you first create the battle goes, I am awakening, and it says on enable. And what does that mean? Well, it means that the battle can do all of the setup that you need to program for the battle. So it finds the various heroes that are in the party, and it creates visuals for them. It looks up the various monster table stuff that it needs to look up to spawn in random monsters or whatever you need it to do. It puts a new image in the background based on where you are in the universe. It does all the setup. The battle controller remains operational throughout the battle. It never turns off. It does lose control because other controls are put on top of it, but it never turns off. It doesn't turn off until the battle resolves, at which point on disable is called, and the battle controller cleans up all the stuff it created and then moves you over into the failure state where you have to load your game because you really suck at this theoretical battle game that we've created. So on enable and on disable pop up at the beginning and end of any given controller's activity. Let's go ahead and give you some other examples. The hero controller. This here, when the battle system activates a hero controller, the hero controller gets this on enable call. And what it does is it says, okay, I'm going to go ahead and show you the buttons that you're going to be able to push. And then when it hits that on disable, it goes, okay, I'm going to hide those buttons. Now I don't create a new hero controller for every time we go through the turns. Each hero has one controller, and I just flip it on and flip it off. So Hero 1, you flip the controller on, it turns the buttons on. Flip the controller off, it turns the buttons off. Hero controller 2, flip it on, turn it on, and it turns the buttons on, turns the buttons off. Back to hero controller 1, turn the buttons on, turn the buttons off. So even though you're within the scene, these hero controllers are getting turned on and off every round. And therefore each one of them gets an on enable and an on disable every round. Same with the villain controller. On enable and on disable every round. Whether you're creating a new controller or just turning one on or off is irrelevant. Every round, on enable, on disable. Same with the animations. Any given animation, you play the animation, the instant it comes into being, on enable. The instant it resolves, on disable. So I hope you understand that concept, because there's a lot of stuff that happens when you turn on or turn off a controller. And in many cases, just thinking about it like that is enough to really start to organize your thoughts and get it working well in your head. Because almost everything you do is going to be related to how controllers turn on and off. But there are 3 more functions. There is on gain control and on lose control. These happen when the controller either gains or loses its spot at the top of the Jenga pile. Now this is useful for controllers that have several things that they need to do. For example, our battle controller. When the battle controller creates a new hero object, or a new hero controller, and then the hero controller passes itself back, it finishes. So battle controller, hero 1, start. Hero 1 does its thing. It says, okay, I'm done. Hero 1 is done. And the battle controller goes, oh, I'm in control again. On gain control. Next. On gain control. Next. On gain control. Oh, we're out of heroes? Next. On gain control. Next round. So by having that on gain control and on lose control, you can allow the controllers to be intelligent about what they're doing when. And those are the 4 functions that you're probably going to use for almost all of your flow control. Obviously, you're going to have other functions, but these 4 are the ones that are going to determine a lot about how you actually handle your game and how your game is set up. The last function you're going to have is the in-control update. Wow, that's a messy spelling, sorry. In-control update is just a specialized update command which runs every frame. but only on the controller that's at top of the Jenga stack. So it's different from the Unity update, because all of these controllers are probably getting Unity updates all the time. If they're on, they're getting a Unity update. Doesn't matter where they are in the Jenga stack, because it is, as a Unity object, they get Unity updates. But in control update only happens to the one at the top of the stack. You're not going to find that this is useful too often. It's mostly going to be useful for things which change over time. For example, if you've got the player trying to mouse their way through a maze, and if they touch the edges, you want to make a buzzer sound, that's probably an in-control update. But for the most part, your stuff is going to be largely controlled by on-enable, on-disable, on-gain control, and on-lose control, because those are the fundamental ways that these control elements can pop into existence and pop out of existence. Let's go ahead and take a look, see how we've programmed it, and see what sort of power this gives us, because it's more than you might think. Here we have our objects, and one thing that we're going to want to start with is the universe script. The universe script is something I use almost all the time. It's very handy to have one central place to go for all of your universal data, things like player settings, or where to go to get monster data, stuff like that. Anytime you need to have it accessible from anywhere, I usually consider putting it in a universe script. So in this case, our universe script is pretty basic. You're going to need to know C# for this. I should have mentioned that a long time ago. If you don't know C#, go take a 2-hour C# course online somewhere and come back. You don't need to be very good, but you do need to know what a class is. Right, let's talk about the universe class, which descends from mono behavior, so we can stick it in the scene like we did. There's a universe in our game world, hopefully only one. Public static list control element controls equals new list control element. What does that do? Well, it's a static list of all of our controls. So it's our Jenga stack. We can access this by just stating universe.controls because it's on the class. It's a static, not a local. So we can go ahead and access this from anywhere. It doesn't matter if we don't know where the universe is. It doesn't matter if there is no universe. We can always access this giant stack of controls. We'll go ahead and do that in a second or two. Just want you to remember that this is on the universe and it is a static variable. You could also put it on the control element class if you'd prefer, but the reason I didn't is because of this update here. Because I know that there's only one universe in the scene, I know that you'll only get one update call. So instead of having like an update on every single control element and then try and figure out which ones are allowed to run and stuff like that, just have the universe handle the update. So what happens here in the universe? Well, first off, it barfs if there's no controls. But if there are controls, it checks to see whether or not the controller has changed. And if the controller has changed, it tells the old controller that it's no longer in control and tells the new controller that it is in control. And then it tells whoever is on top of the stack that they can do their control update. Now you might remember I said that there were 5 functions. Those are the last 3, on gain control, on lose control, and on in control update. That's them. So the universe is responsible for calling those 3 functions. It doesn't matter what the controls are trying to do or how they're built, because these 3 functions always get called the exact same way. Now, if you know any C#, this should be pretty straightforward. This is not a complicated concept. It's very, very basic. The only thing you have to remember is that Unity will automatically call this update function. Right? Let's go take a look at our control element class. It's very, very simple. It's also a mono behavior so that I can stick it inside of objects in the game world. And I said that there were 5 functions. 1, 2, 3, 4, 5. In fact, on enable, on disable, on gain, lose, and in control, the same ones, in the same order even. Those are our 5 functions. I kept this super simple just to be really, really clear. These are the 5 functions. Okay? Now, these 3 functions at the end, the universe calls. The universe is the one responsible for making these happen, which is why they're public, because that way they can be accessed by the universe. On enable and on disable are Unity functions. Unity will automatically call these functions for us whenever anything changes. So if you create an object or turn an object on enable gets called. If you turn an object off or delete an object that's currently on disable gets called. This is the most important thing you have to remember. We are leveraging Unity's power. We don't want to try and keep track of all this shit ourselves. Unity already does the work. So this is it. When we turn a control on or put it in the scene, this gets called. When we take it out of the scene or turn it off, this gets called. Now here in the base class, all we do is either add it to the Jenga stack or remove it from the Jenga stack. This means that whenever we put a controller into the game world, it will automatically rise to the top of the stack immediately. There's no complicated situation where it tries to determine where in the stack it should be. If you put it in the game world, it goes to the top of the stack. Very basic. That's the whole point. We're trying to keep it as basic as possible. So let's take a look. Here, this is one of our control elements. This is one of our hero control elements. And our hero control element on Alice and on Doug, these are what get activated by our battle controller. Our battle controller will go through each of the heroes that it keeps track of, and it will activate these elements. But there's some stuff here, so what exactly is this? What do you think? Well, the hero controller is a little bit more complicated because it descends from control element. So we're inheriting all of control element's powers and those 5 functions that we need. But we're going to override some of them. Now what we've done is we've used Unity engine.events because Unity events are really, really, really useful. Like, really useful. And I'll show you that in a minute here. We've got this gets turn thing. That's just so that we can kill characters off. When we're actually running through each character in turn, trying to determine whether they get a turn, they only get a turn if gets turn is true. Here, public Unity event on activate and on deactivate, and you can see them on activate and on deactivate. Now, if you're not familiar with Unity events, they're the same thing that you get from buttons. See, on click. So it's the same thing you do for buttons, except we created these Unity events, and we trigger these Unity events. Okay? So these Unity events are things we created and we trigger, but they're the same interface as the basic Unity interface, and they can do all of the same things. And in this case, what they can do is they can turn the battle commands on and off by adjusting their canvas group. The canvas group is just a simple way to turn things on and off. See? A lot of people don't know about the canvas group. You should read about it if you don't know about it. But that's what we're doing, on activate and on deactivate. Now we could have put these Unity events on the base class. There's no reason that we couldn't have. I just didn't want to make the base class complicated because I wanted you to be able to see it. Like super clear. So how did we do this? Well, we got an empty control update. We got the on enable and the on disable. These are 2 of the functions that we, 2 of the 5 magic functions that we are talking about. We call the base, and then we say on activate.invoke, and here on deactivate.invoke. So these literally happen every single time that the object is enabled or disabled. It's literally the same as writing code in here. So we've told these things to turn the battle thing on and off, right? We could have written that in code. We could have said battle thing dot enabled equals true or whatever. But we chose to do this, I chose to do this in a Unity event specifically so that you can wire it up here in the scene view. There are certain situations where that's not a good idea, but most of the time, using a Unity event will give you a lot more flexibility. You don't have to go into the code. You don't have to try and debug your stuff. You don't have to work out how to create different variants. For example, let's say that you have a special character. Let's create them right now. This special character, their name is Berserker Man. And Berserker Man, his name is Berserker Man. Oh, or Berserker Ma. He doesn't get those buttons. Instead, what happens is he immediately attacks. So what we're going to do is we're going to change it so that our on activate and on deactivate have different arguments. And now what we're going to do is we're going to say that Berserker Man takes the attack action. Yep. Now when we hit play, got Alice, got Doug, Berserker Man just attacks automatically. There's no animation for it right now because I haven't put one in, but we could put an animation in as well. So that is a really powerful way to do things. We don't have to have all of our characters be the same. I added Berserker Man in 5 seconds. Now, obviously, there's no graphics associated with him, but the functionality of having his character around didn't require any additional code at all. And just so you're aware, he does actually exist. So, for example, if I undo that, I think I forgot to add him to our control stack here. Yep. Let's try that again. Correctly wired up. Yeah. And if you wanted to see for sure whether he's there, Berserker Man has control. Berserker Man no longer has control. So it's a very fast, very easy way to do it with no coding. I didn't have to go into the C# code and create a variant for Berserker Man because it's all done here in Unity events. And Berserker Man can be saved. I can drop Berserker Man into our asset pack as his own character, and that will be saved. Berserker Man will always just attack, even if I rename him. Now, there are situations where that might not be what you want. For example, you might want to have some kind of system of effects and stuff where people can go berserk, but that's a different concept. I'm talking about the flexibility of being able to wire these things up using Unity events. Anytime you think of your system and you're like, well, I need to create variants for A, B, and C, instead of thinking about code variants, think about just putting in Unity events for the pieces of things that need to vary. So in this case, the attack pattern, what pops up. I turned Berserker Man into an NPC basically by just telling him to attack. Using Unity events to allow us this freedom keeps us from doing very much code at all. This entire thing is coded very, very lightly without really any code that will be hard to maintain. And it means that our code can be replaced at any time without needing to remember all of the 10,000 variants, because the variants are saved with the character in the individual instance rather than as code. Not always the right idea, but it'll get you a lot further than trying to manually program every single possible variant character. Let's go do another example. Let's talk about the battle scene. The battle controller is a little bit more complicated. It's the most complicated of my classes at about a page. And you can see that it also descends from control element. This is what is active at the beginning of the scene. And what happens here is we've got an on player turn start and an on player turn complete. We're going to talk about why we have those in a minute. We have this battle control heroes. Now you can scan for the heroes. I've chosen to manually add them for now. There's no reason you can't. I just didn't want to write any more code. And then we keep track of the turn, which of the heroes we're currently on. When we enable ourselves, we reset our round. Okay, now resetting the round just goes through and hides all the hero controllers. So basically, if the hero controllers are on, we turn them off so that the heroes don't decide they're going to take their turn now. And the good news is the way that on-enable works, that should work fine. Even if the heroes are on and they have their on-enable called, they'll immediately have their on-disable called. So there are times when that might cause a mess, but in this case, it's just fine. We also set our turn number to -1 because we want to start at the very beginning. So on gain control happens when we're at the top of the stack for the first time. And what we do is we do our on player turn start, and then we say next. Here in next, what we do is we have all sorts of code for determining which heroes we're kind of trying to do here. We turn the old hero off just in case it's still on somehow. And then we go through to the next hero. If we don't have any more heroes, we reset the round and call on player turn complete. If we do have heroes left, we go ahead and activate them. So if they get a turn, turn them on. If they don't get a turn, just go to the next one, just skip it. This is a very basic setup. All it does is turn the old hero off and turn the new hero on. Super simple stuff. Now, why did we do it like this? Why is it here on gain control? Well, that's because every single time that one of the heroes comes into existence and then leaves existence, on gain control gets called again. So when we turn the hero on, eventually it'll turn itself off, it will regain control. Create the next hero, it turns itself off, we regain control. Turn the next hero on, turns itself off, we regain control. So the basic flow here is that when we first get enabled, we reset ourselves, which turns all the heroes off. And then we turn the first hero on, and then we continue to go through each hero. Super basic stuff, and I'm absolutely sure that if you've ever tried to code this, this is what you coded. There's no surprises here. Except one. This. Give control to the enemy turn on player turn complete.invoke. Now, if you were making this back in ye old days before you knew about the control stack, you probably would have said something like bool player turn currently player turn equals false, and then you'd have like this switch where if the player turn is currently false, then you would go through the enemies instead of the players, and you'd activate each enemy in turn instead of each player. I didn't do that. Instead, I have a villain control, and this turns on the villain control. But it doesn't even turn on the villain control here. This doesn't have a concept of a villain control. This just says, whatever you've got wired up is fine. What do we have wired up? Villain panel enabled equals true. So we give control over to the villains, and this adds itself to the top of the Jenga pile, takes control, and the battle system loses control. The battle system eventually regains control, goes back to the beginning of the turn. But this has control now. Now, why did I do it like that? Why didn't I wire it in so that it manually called the battle control for the villains? Because I want to be flexible. In Act 1, I've got these battles where it's you against monsters. But in Act 2, there's like a neutral party, and it's like you, and then the neutral party, and then the monsters. And then in Act 3, it's like a cloud of smoke, and then you, and then acid bath, and then monsters. And then in Cloud 4, it's you, and then allies, and then a giant stone block. And I wanted to be able to do all that stuff without having any kind of complicated coding. So what did I do? I decided not to code what happens after the player's turn. Instead, I specify it here in scene view. I say, what happens after the player's turn? The villains get a turn, or the neutral party gets a turn, or the giant stone block gets a turn. Now you can code in code that's just like, if a neutral party exists, then do the neutral party. I think this is easier. I think this is cleaner for most games. So, there are some other things that you can do that are specific to Unity. One is animation events. So we have this villain panel here, and over here we've got this animation event. When the villain panel activates, it tries to play this animation, and over here at the end of the animation, it calls done, which just makes the panel deactivate itself. So that is the way where we wait for something to happen and then disable the panel. There's no code in the villain panel that keeps track of what's going on. We just know that when the animation is complete, we destroy ourselves, we hide ourselves, we turn ourselves off, whatever we need to do. And later on, if we need to change the animation, as long as we move that animation event, which is right here on the same screen, we're golden. Same is true for attack animations or anything else you want to do. If you use animation events to do them, you can get away with very, very little code, and none of that obnoxious, like, waiting during an update code. You can also do really, really complicated stuff with Unity events. I showed you the Unity event system for just using standard Unity events, but standard Unity events can't take arguments. You have to specify every single piece. You can't in code say that it's supposed to be A or B or C. It's just always whatever you've typed in the inspector. But you can create other kinds of Unity events, and here's how you do it. So you can do anything you want, any kind of thing you want. This is a string, but anything serializable will work. You can have it pass submenus. You can have it pass a specialized attack class. You can have it pass 4 strings and a float. And you just do it like this. And then down here, when you invoke it, you pass it whatever you've told it you're going to pass it. And this stuff shows up in the inspector so that you can set it up there. It also can be added in during play. So I could say, oh, you click the skill menu. Well, let me create the skill menu and then sign up for this event. And then the event will happen, and I'll get a message back, and I'll go ahead and delete that sign up. And the submenu would never know what the heck was going on. The submenu doesn't know that there's a character waiting for it to have a skill chosen. It doesn't have a concept of whether it's in a shop or a dialogue tree or any of that stuff. All it knows is that you're going to click a button and it is going to give that message to whoever is listening. And you can use this to wire yourself up in really, really useful and powerful ways. In this case, what happens is this gets sent to the player object, and the player knows that they took the hero object, and the hero knows that they took an action. There are a lot of things to learn about how to do this, but I wanted to give you a taste of how you can do it in the most efficient way possible. Even putting aside the advanced options that I just told you about, this method will let you build your game. It will certainly give you a better place to start with than just staring blankly at the screen. Just remember, actually write it down. Actually use a piece of paper and draw that diagram. And remember those 5 special events. And they're not the only things that move, because obviously there are things that turn them on and off, like animations shut themselves off at the end, and if the player presses a button, things happen. But those 5 functions will give you almost all of the core functionality you need to think about what your game is going to do and when. Use Unity events whenever possible to decouple complicated logic from situations where you would need big switch trees. You don't want to program in specialized logic for every possible game or every possible kind of battle. It's better to use Unity events and have different variants and spawn in different variants, prefabs that have different settings. I'm worried that this might have been a little too advanced if you are very new to Unity, because I did go into some detail about things that Unity does without talking about other things that Unity does. For example, if you don't know what a prefab is or how to spawn one into the game world, you're probably still kind of lost. But hopefully, if you are relatively familiar with that sort of thing, this will help you to build your game. Let me know what you think down below, and see you later.